Hello guys, hope you are doing fine. So today we will be discussing a special type of problem, which is generating prime number. So this is the class. You can see like we are having an empty class, and within this class we have the main method. So let's start with the method which is going to generate prime number. So I'm keeping this method as public static void, and I'm giving a name like generate prime number. So essentially this class is going to take one value, and say for example that value is integer n, and we are going to put logic for generating prime numbers. Now suppose the value of n is basically saying like, user is saying like I want 10 integers up to 10. I want to know like who are the prime numbers. So uh, let's take an array of boolean type and initially make all the parameters, all the values as a prime number. So that is going to be a part of initialization. So this prime array, whatever we are taking as a boolean array, is taking all the elements which is having n plus 1 size, right? All the elements which is having n plus 1 size, and these elements I want initially as prime numbers. So all the initial idea is like all the members is going to be prime, and then we will set logic to discard the numbers who are not prime. So our strategy is to discarding numbers or discarding non-prime numbers. So as far as the statement, we can write a for loop starting from I is equal to 2, I less than equals to n, and then I plus plus. So in this loop, what exactly we are saying? We are saying this prime number's value is going to be true. So I'm saying prime I is equal to true. So all numbers are prime initial. Fine. Now we need to put the discarding logic. So we will try to find out. So when a number is given and we want to see that number is prime or not, so the loop we want to move, suppose the number is 10. So the loop will iterate from 0, from 2 to root of n or root of 10. If in case of the value is 10, in case of the value is 35, the loop iterates from I is equal to 2 to root 35. Why? Because we don't want to iterate through n, because if we check from 2 to root n, that is going to be sufficient enough to check the availability or to check the whether this number is prime or not. So whatever the number will lie, that will lie between 2 to root n. So that is going to be the range for checking for any numbers whether it is prime or not. So initially we are taking a loop starting from j is equal to 2, and j, as we are mentioning, j less than equals to, we can say like square root of that number. So math dot is qrt, and then we can say like it's kind of a n. So math dot square root of n, and we can do j plus plus. Absolutely, we can do with j plus plus. So this is the loop where we are checking the whether the number is prime or not. So initially, when we are done with this loop, we will now see like within this arena, within this range, whatever the prime number exists, or whatever the prime numbers are there, so they are basically having any multiplying factors, or they are having any numbers which is going to be multiplied by 1 or 2, something like that. So that those numbers will be discarded. For an example, suppose we are having another for loop, and that loop starts from integer k is equal to j, because j starts with 2, and we want to see like k into j less than, we will make a dry run, and that is going to be clear in that case in, and we are incrementing k. So within this loop, actually what we are doing, okay, yeah, within this loop we are missing a bracket, right? I guess yes. So within this loop, what we are doing, what we are trying to do, we are trying to put a discarding logic, and that discarding logic says what? At least discarding logic will say like whatever the prime array is having, we want to say like j star k should be is equal to true, should be equals to true. Sorry, we have set initially false, sorry, to true, so it should be false. So all those multiplication, all those numbers who are having some multiplying factor with k is going to be false. What does that mean first? So before that thing, we need to put one another logic, like whether this is, we will be checking, we won't do it repeatedly. So we will say like prime j is equal to this. If prime j is equal to true, then only we will, because once it is false, we don't want to get into this logic. So we can see, like we can make our code alignment over here. And finally, we can print with for loop integer I is equal to 0. Sorry, integer I is equal to 2. And we can say I less than, sorry, I less than equals to n, and we can say I plus plus. So in this loop, actually, what we can do, if prime is equal to I, then we'll be having something like this, right? So we need to set another, yeah. So in case of this, we'll be having system dot out dot print, and here we need to print like I plus, right? So if we just call this number, and say for example 10 is our asking number, we want to print everything, every prime number which decides between this 10. So okay, there is an exception. We have something string many hours. Okay, there is a problem with bracket. There is an extra bracket, so that's 2357. So let's try with another number. Let's make it 20. 2, 3, 5, 7, 11, 13, 17, 19. So how it is working? I'm just trying to make a dry run. If I just take a paint over here, paste it over here and take an array. Suppose we are having an array, and initially in this array, every element, okay, every element is false, okay, every element is false. So what is false? 0 for 0th location. If you say, Okay, then it is 1, then it is 2, then it is 3, 4, 5, 6, 7, 8, 9, 10. Suppose you have this amount of length 0 to 10, 11 numbers. So that's why you just took n plus 1. I'm using a different color over here. That's why you take n plus 1. Okay. Now the thing is, initially everyone was, okay, let's make it green. Initially everyone was true. So initially every value, every number is basically of this prime array was like a prime number. So what this program is doing, in this case, first we are moving into this loop. So in this loop, actually, this loop is basically defining the range of the prime numbers. As we know, that the prime number will start from, prime number will lie between 2 to root of 10. So if we check up to this range, we will get all the prime numbers, right? After that, we don't need to make any further check. So that's why we keep our loop till this. Okay, that's the first point. Now, at the very beginning, when the prime number, when the prime array, so this is your prime array, when your prime array has not been modified even not for a single time. Okay, so in that case, what is happening? It is checking whether the prime number is true or not for second location. Second location means this location, and yes, this location it is true. So it is going to this direction, k is equal to j. So j, actually j, k into j, it is going to be your range, k plus plus. So here actually j and k value is 2. So that means 2 into 2. 2 into 2, that means fourth location is going to be false. I'm taking a different color over here. So this is going to be a false. So you are actually, what you are doing, you are editing or modifying your prime array over here. So you are modifying 4, which is not a prime number, and you are checking like 2 into 2. This is your 2 into 2. 2 is your prime number, but 2 into 2 is not going to be the prime number. So that is why you are discarding it. So that's why, and you are making it false. Next element is definitely going to be 3, right? Because your k value is going to be incremented. So it is going to be 3. So 2 into 3, that means 6. So this 6 is going to be discarded from the array. So 2 into 3 is going to be discarded. So you are making it false. Okay. Next one. Next one is k is equal to 4. So 2 into 4, that means 8. Eighth location you are having one index, and that is going to be false. So this is also going to be modified, and it is going to be false. And 2 into 5, that is also your 10 is n is equal to 10. So that is also going to be counted. So 10 is also going to be, discarded or modified. So this value is going to be false also. So initially, when your j is equal to 2, you are having all these values. So when j is equal to 3, so you will check like in if j prime j is equal to 3, yeah, it is true. So you will enter into this loop, and in this loop, actually, you will see like when you are having k value is equal to j value, that means k value is also going to be 3. So j into k means 3 into 3, ninth location. So I'm taking another color over here. So this is the ninth location. So that is basically 3 into 3, 3 into 3, and that is going to be false. So this is going to be false. This is going to be false. It has been overridden. Now the next one is 3 into 4, that is 12, which is actually beyond the range. N value is 10, you are checking 12. So that is not going to happen. Next one is 4. 4 into 4, 16. 4 into 4. So next one is 4. 4 is not going to be entered because 4 has already been in false state. So that is not going to be entered. 5 also is not going to be entered because 5 is going to be entered, but 5 into 5, 25. So that is not going to be counted. So in this way, you have false, you have false or you got true. So you got true for 0. If you just write it down, you got true for 0, you got true for 1, you got true for 2, you got true for, no, yeah, you got 2 for 2, you got 2 for 3 and 5 and then 7. So that is the thing. And up to 7, after 7, everything is false. Now you are printing from 2 to 7. So that is why the answer is 2 to 7 in this case. If you just come over here, if you just come over here, your output was for 10. If you just keep 10 over here, your output is going to be 2357. So that's it.